Array chunking is a common problem in JavaScript where you need to split an array into smaller subarrays of a specified size. In practice, this can be encountered in various scenarios, such as paging through large datasets or when dealing with data in fixed chunk size for processing or display. The challenge is as follows. Given an array and a chunk size, you need to create an array of smaller arrays, which we call chunks. Now each chunk contains elements equal to the specified size, except for the last chunk, which can have fewer elements if there aren't enough left to fill a complete chunk. For example, if you have an array of 1, 2, 3, 4, 5, and a chunk size of 2, you should split it into an array of subarrays with 1, 2, and then 3, 4, and 5. For this particular problem, so that we can focus on the challenge itself, assume the chunk size is greater than 0. Let's start implementing this solution by writing a skeleton method called chunkarray, and we'll pass it the array and the chunk size. Since it's a skeleton method, let's just return an empty array at the moment. And we'll use our basic test case just to validate that it works. All right, it's returning our empty array as expected. One straightforward approach to solving this challenge is by using a for loop. We can iterate through the input array, creating a new subarray for each chunk. Now, to determine the chunks in the input array, we can use a method called slice. The slice method returns a shallow copy of a portion of the array into a new object array, and it takes in a start index and an end index. Let's go and try this. Let's declare a results variable to store the final array, and the for loop will start at the beginning to the end. But since we're going by chunk, it will increase by the chunk size. And for the chunk, we'll use the array slice method. And remember, it takes in a start index and an end index. So the values will be I and I plus chunk size. And we'll just push it at the end of the results. Okay, let's give this a go. And that looks pretty good. And as always, we should test it for more scenarios. And luckily, I already have those prepared, so I'll just paste it right here. The first test case is the same we had at the beginning. The second test case, we're passing a chunk size of 1, so we're expecting arrays of 1, 2, 3, 4, and 5. For the next test case, we're passing a chunk size equal to the size of the input array itself. So we're expecting an array of a single array with values 1, 2, 3, 4, 5. And we have a test case for an empty array, which should return an empty array. And the next test case, we're passing a chunk size, which is greater than the size of the array. So we're expecting just that array to be returned. And for last test case, we've got a chunk size of 2, which should split evenly and return results of A and B and C and D. Okay, let's give this a go. And perfect. Now we can also clean up this code a bit. Instead of I equals to I plus chunk size, we can just have I plus equal to chunk size. And we don't need to store an intermediate chunk value. We can just push that straight to the results. Okay, that looks a bit cleaner. And if we run it again, that all looks correct. The time complexity of this solution is big O of n, where n is the length of the input array. We iterate through the array once, creating subarrays of the desired chunk size. An array slice also has a linear complexity, so the entire solution is big O of n. We could also use the splice method to solve this. The splice method is similar to the slice method, But instead of just returning the subset of the array, it actually removes that subset from the original array. It takes in a start and delete count as parameters, so it's slightly different from the slice's start and end index. Let's give this a go. Since the splice method is deleting elements from the array, we can't use the for method anymore. Or we could use the for method, but it won't be the best approach. A nicer approach is the while loop. While the elements left in the array, we'll use the splice method starting at index 0 to the chunk size, and then we'll push it into the results. Each splice will remove a chunk from the original array until there's nothing left, in which case the while loop will exit. Okay, let's remove our previous code and give this a try. And the result looks all correct as well. This approach is very similar to the previous one and also has a time complexity of big O of n, where n is the length of the input string. Although it involves more manipulation of the original array, the splice method itself still operates in linear time, so the whole complexity is big O of n. Perhaps a more elegant or fun approach is to use the reduce method to build the chunk array gradually. The reduce method executes a callback function on each element of the array, and the final result will be a single value that gets returned. We can use the accumulator, the current value, and the index to help us build the chunked array. Let's try and implement this. We'll remove the previous code. The reducer method takes in the accumulator, the current item, and the index, so we'll just call this result item and index. To build up the chunk array, we can test to see if the index is a multiple of the chunk size, and if so, it will be a new chunk. If not, we get the current chunk at result of length minus 1 and append the item to it. Let's test this. And the results look all correct. The solution has a time complexity of big O of n, where n is the length of the input array. The reduce method iterates through each element in the array just once. Thank you again for watching this video. If you have any feedback or comments, please don't forget to leave them in the comments section below, and I'll see everyone later.